Good afternoon, all.
Good afternoon, ma'am.
Good afternoon, ma'am.
Good afternoon, ma'am. Good afternoon, Hema ma'am and Manikandan. Thank you for the warm introduction. So today I have planned my presentation in this in a specific order, like because this is actually a very serious problem what we are facing. So the effective role of deep learning algorithms in COVID diagnosis in the era. So that is whatever we faced, or like myself, I have witnessed, and also I'm also one of the victim of this particular that is COVID disease. So like we have faced step by step. We see that is we have faced lot of problems. So those problems where we missed, and when actually it has become very serious. Why that is what is the role of learning algorithms here? That's what I'm going to discuss. Why deep learning is required. So we don't want actually deep learning algorithms for every problems what we use in our day-to-day life. Whether our Arogya Setu app we are using, we have used. So whether that one used deep learning algorithms, it is not so. So we don't expect every problem of our choice should have a deep learning algorithm, but it should be that is whenever we have a voluminous data set, in that case it is required to go for learning algorithms. So that is also deep learning algorithms are very much required. Okay, so now in this pandemic era, like where actually some of the things can be managed, that is whenever we go for an automatic diagnosis or an automatic detection of something. So in that case, it is definitely we need to go for that is learning algorithms, better learning algorithm. It can be a machine learning algorithm or it can be a deep learning algorithm. Why the deep learning algorithms are having that is predominantly having a better role than that of machine learning algorithms. I need just 1 minute time. Okay, please.
Participants, resource person will join soon. Kindly be in meet. Dear participants, there is a network issue in resource person side. Kindly regret and please be in meet.
Ma'am, screen sharing, it is disabled. Ma'am, Hema ma'am,
Ma'am. Ma'am, yes, ma'am.
screen sharing, it is disabled. Binur.
One second.
Okay. I'm very sorry. There is some network problem. Okay, so we have that is witnessed in the past 2 decades with the that is outbreaks of many viral diseases like chikungunya, Ebola, Zika, Nipah, H7N9 bird flu virus, and H1N1, SARS, various versions of SARS, and MERS with various versions. In 20, so as of now, we know only that is corona virus that is version 2. And in 2019, there is actually the coronavirus was first. It was actually many people got infected. That is actually which is it is actually severe acute respiratory syndrome coronavirus, SARS-CoV, and Middle East respiratory syndrome coronavirus, that is actually MERS-CoV, and influenza A viruses. It has actually that is actually one which has major pathogens which will target the human respiratory system. Okay, so the diseases associated with their infections vary from mild respiratory illness to acute pneumonia or even respiratory failure. So in the early that is stages of this COVID-19, like many people, so they were actually infected or that affected by the pneumonia. But it was actually the physicians were they couldn't able to that is detect whether it is actually COVID or normal pneumonia. So that is actually the biggest problem they had in the early stages. And later only, that is with the support of CT images only, they could able to identify that is actually, it is this pneumonia, it is due to that is SARS-CoV virus. And that is actually the post, now actually in the late 20, or you can say that 20 or 21 and the early 21. So they have concluded that it is nothing but the impact, it is just because of the post-COVID problem. In 1918, the influenza A virus, it has caused 4 pandemics. The first and most severe pandemic is actually a Spanish influenza that we all have heard about that. And in 1918, that was H1N1 influenza A virus. Okay, and approximately 500 million were infected and 50 million died during this pandemic time. Okay, and the second pandemic was Asian influenza, which occurred in 1957, and this is actually H2N2 strain virus strain, and which resulted in approximately 1.1 million deaths worldwide. And the third pandemic was actually originated in Hong Kong. It was a Hong Kong flu, and it was in 1968, and this is actually H3N2 strain, and it was resulting approximately 1 million deaths worldwide. The fourth one was actually H1N1 PDM099 virus. So this resulted actually 1,51,000 approximately maximum of 5,75,400 deaths worldwide occurred from 2010 to 2010. This is actually, these are all happened, but we were not aware of, or less aware of these viruses. Okay, since that time, that this novel influenza A virus has continued to spread as a seasonal flu virus. From September 2019 to February 2020, this virus caused at least 34 million flu illnesses and 20,000 deaths. In November 2000, the same, that is influenza A, it actually it created a pandemic scenario, and this is otherwise called as a beta version of coronavirus, and this is SARS, and it actually originated from South China, and it spread to 29 countries. Okay, so approximately 774 deaths and infections were 8,000. So this is not actual what we are facing now. And in the later case, in 2012, Saudi Arabia reported that is first case for MERS virus. And here, this was also considered as a beta version, and it spread to this virus. It actually spread over to 27 countries, and 2,519 infections were reported, and 8 deaths by 2020. In December 2019, so new coronavirus, that is 2019, that is COVID-19, caused by a new beta coronavirus version, which was first reported in Wuhan, China. Okay, this it rapidly spread worldwide. Not rapidly, very, very rapidly, it spread worldwide. It has infected more than 24 crores of 20,33,650 individuals globally, and resulted in more than 50,54,267 deaths. In India, around approximately 3.5 crores were infected cases, and 4,61,000 were death cases, actually, which was reported as on 10th November 2021. Okay, in Tamil Nadu, approximately 27 lakhs were infected cases and 36,000 were death. And in Pondicherry, 1.28 lakhs infected and 1,862 death cases as of now reported. Okay, so SARS itself, it has various versions, and it is considered to be appear to be or contagious and most infectious virus. Okay, and because there was actually the pandemic situation, which was actually opened or declared by the WHO, and globally it was actually considered to be an emergency situation. And so because of the infected people were tested with actually 5 types of tests. Okay, so for diagnosing or against the concluding, that is whether COVID infected a person is COVID infected or not. or COVID deceased or not. So there are 5 types were considered. One is actually molecular, that is Rt Pcr test. Second one, antigen test. Third one, antibody test. Fourth one, chest X-ray, and fifth one is CT scan. Okay, so the preliminary level, that is very or in the early 5 days. So these tests were helpful. But actually, whenever actually we are going with a, that is when this case is very serious, the Rt Pcr test will be false. You will be getting actually a negative result. Antigen will be a negative result. But sometimes actually it will be reported in chest X-ray or scan. So that's what we are. I'm going to conclude why it is actually very important. Chest X-ray is very chest CT is very important. Okay, so let us go with from the first level of test, that is molecular Rt Pcr test. Actually, it tests the RNA of the virus, and which is actually the genetic material of the virus. So it uses the enzyme called reverse transcriptase to convert RNA to DNA. So this test is accurate with high sensitivity and specificity. So what is sensitivity? What is specificity? Sensitivity is nothing but it is actually true positive. Who are all actually the probability of person having actually a positive sign, a probability of having a person that is COVID infected, COVID deceased. That is actually sensitivity. So that is actually we have, and our specificity is nothing but it is or you can say that the smallest value, or the not false positive, or you can say that true negative, we can say, because actually those who have negative results. Okay, so here in this Rt Pcr test, actually what is actually the main problem is actually so we may get a negative result, but it does not necessarily mean that they will not be infected. Okay, they might have, that is, they may have completed the first few days. In those first few days only, it will be just producing, it will be giving a positive result. So it does not indicate whether the person has been infected with the COVID-19 100% in the past or in the in the past. Okay, so this is actually the specimen, how it is collected. That is a swab test. A swab is collected, and it extracts RNA from the specimen and converts to DNA, and it amplifies the PCR with the primers, specific primers of COVID, SARS-CoV virus, and the next one is, the last one is interpretation of the risk, which indicates actually whether virus infected or not. Okay, the next, antigen. So this agent refers to any foreign body or viral protein that triggers an immune response in the body. Okay, so that is different, and this is different. So this is actually any foreign body or viral protein which actually triggers the immune response in the body. So it helps in identifying the antigens associated with the virus, which is faster than, that is, Rt Pcr molecular testing. Again, here also, when the result is positive, a quick test is usually accurate, but a negative result may need not be, so we need to go for another test, so that will be helpful. Okay, so this is actually the model, like how actually immunologic test is actually carried out, and rapid detection is done. Okay, so this is actually, this test line indicates that is actually, it is actually the positive case. So sample pad will be just giving the samples, and with that actually the test results will be concluded. Okay, now antibody test. So this is one of the best method, that is whether actually we can check whether actually earlier stage whether the individual has been affected by the virus or not. So this is actually a serological test, or we can say that serum blood test. So it is used to detect antibodies against coronavirus in the blood. This shows whether the person has been infected with the virus that caused COVID-19 in the earlier stage. Okay, so but here, like if you have been infected already, that is the corona positive in the earlier stages, then it will be creating antibody. That is, it will definitely have an antibody in the body. So this will be just working according to that. So we can have an active virus in our body, okay, which causes COVID-19 infection. Okay, this is actually the immunology test. That is, we will be having the blood sample collection, and it will be just a sample will be put into the specimen pad, and the test line will be having a, so positive sign, that means there's actually the interpretation of result is nothing but whenever there is actually color change in the test line, which indicates actually previous exposure to COVID virus. The patient or the individual is has a previous exposure to COVID SARS-CoV virus. Okay. So and next one is like you have so the methods which are actually used for this particular that is a chest X-ray. Sorry. Okay. So one of the that is a critical factors, that is a chest X-ray, the tool or the input content which we can give for that is testing identification of COVID positive or not, is that's chest X-ray. Okay, so we can just provide, we can have various automated systems for detecting COVID-19 samples from healthy cases to pneumonia cases using chest X-ray. Okay, so we have a limitation in the data set. So that is, and on one more thing is that is a commonly used or widely used method is like deep learning method is CNN method, that is convolution neural networks, to find the suitable, let me explain that later, why it is used and in what way it is actually helpful. Okay, so chest CT, like what is a challenge actually, which is actually present here is nothing but you can have a more detailed view of that is because lungs or the first level infected organ, and so we can just have the complete view of the lungs, and we can identify any abnormality in the chest, and the exact location we can just find out. If, like, suppose take an example, 25% of the lungs is infected, if a physician is telling like that, so it is actually based on the conclusion that is coming out of the chest X-ray and nature of formation where it is infected, that means it can be concluded. Okay, so chest X-ray, it provides 2D image, while a chest CT scan, it will be providing a 3D view of the organ. Okay. So now this is actually the model, how it is working. That is X-ray model. You have the X-ray of that is either the patient can be a healthy patient or pneumonia, bacterial pneumonia, or viral pneumonia. Now we are concluding that is coronavirus. Okay. Now this is actually pre-trained, and it is actually how the features of the images are extracted, and it is analyzed, and it is classified whether it is COVID-19 infected or not. So we have the best learning techniques actually, DarkNet, ResNet, AlexNet. So these are the various models. Okay, one by one we'll be anyhow, I will be just checking this. Okay. And CT scan, it is actually the very important or the helpful tool to diagnose COVID-19 infected individuals with a high clinical suspicion of infection. So the CT scans use a computer to merge 2D X-ray images and convert them to 3D images. So we have actually, but we require a specialized equipments. Okay, and a specialist, and that is an expert is required, a radiographer is required to that is to just get and to analyze the system. Okay, so we have pre-trained CNN models to find the most suitable the area which is actually infected, and here one challenge is that is passing X-rays passing the CT rays to children, which will lead to some other problems and complications, and because the children will be having very small size of lungs, so which will be have other complications. Okay, now this chest CT, it is actually we have 3 categories here, that is normal, bacterial pneumonia, and COVID infected pneumonia. So now this images are like we use a parallel deep feature extraction. So I just want to make a note of this one, parallel algorithms, why it is very much required in the case of deep learning, why we need to go for parallel models in deep learning algorithms. I'll just tell that. Okay, so now so after a proper learning method and classification method, so it is actually classified as normal, COVID-19, or bacterial pneumonia. Okay, so now just why we need to just go for deep learning models. Why we can't go with the traditional machine learning or shallow models? That is actually biggest question, because that will be having equivalently having a better opportunities or better results. In some cases that will be producing better results. What is the difference? Why we need to go for deep models for this type of critical cases? Okay, because the running time, we can reduce the running time, number of parameters can be considered, and feature representation, learning capacity, interpretability of the results, the conclusions. So here the running time includes both the training as well as testing time. Okay, due to the complexity of the deep learning models, like we can have definitely the training and testing times are much longer than that of the ordinary shallow models. And we have two types of parameters here: learnable parameters and hyperparameters. Now the sensitivities, specificity, these are all hyperparameters. Okay, learnable parameter means the learnable parameters are calculated during the training phase. Okay, the hyperparameters are set manually before training begins. Okay, so and feature representation. So the traditional models will be having a feature vector, and there is an there is a need for feature engineering module. Okay, in contrast to that, like in the deep learning models, we have we can just learn the feature representation from the raw data. And so it is not required to just go for feature engineering. So the representations can be learned from the raw data itself. Okay, so it will be and one more thing, that is deep learning models will be executed in an end-to-end model, so it has more advantages than machine learning models. And the learning capacity, so now usually we'll be having, that is the learning models, every learning model, it has its own advantage and its own disadvantage. Okay, so we may feel that is deep learning models are complex, it is structured, and it is actually many layers are there, and we have huge number of parameters. Okay, even then, so it has actually stronger fitting ability than do shallow models. Okay, it has stronger fitting ability than do shallow models, and it has actually, these models face a higher risk of overfitting and require larger volume of data for training. So because of that reason only, we are going for data. So in that case, we can have better training models because of this volume data, and we can just that is our that is what the diagnosis will be better when we compare with the traditional shallow models. Okay, interpretability, this is actually a very important component in deep learning. Okay, it looks like the deep learning models are black boxes. Okay, and the results are almost uninterpretable, which is a critical point in that's actually one of the biggest challenge in deep learning. So we the traditional deep learning models, that is decision tree and naive Bayes algorithms, they'll be having stronger interpretability. So interpretability means it is nothing but that is what actually conclusion we are getting, what meaning we are getting out of the algorithm. Okay, so that results how it can be interpreted for the end user. How that is, if we are we are going for virtual assistant. Okay, automated virtual assistant. Okay, this automated virtual assistant should provide a result or provide an answer for a particular question in such a way that he or she should understand appropriately, and to their knowledge they should be able to that is grasp that output, and they could analyze the things. Okay, that is interpretability. So this plays a very important role, and it has large scope in this deep learning. Okay, for every application, either you go for intrusion detection system or security system or this diagnosis, medical diagnosis, everywhere this interpretability plays a very important role. So we can design our own tools for new that is for the new models. We can write our own algorithms, and we can write our own models which will be helpful for the end users. Okay, and next one is a role of deep learning. Role of deep learning in COVID-19 disease detection. So we know very well, that is WHO declared in February 2020. It's as it's a global pandemic disease, and we have it was in the earlier stages. It was very difficult to detect and infected people and to segregate or to isolate the people. Okay, so now why we are going for that is deep learning techniques means like it is nothing but we can just whenever we have a specific person infected in a particular location, so we can just collect the samples of the particular area collectively, and we can just put it in a particular database, and we can analyze that one. Okay, so it will be just this deep learning construct networks. It will be having many layers of which will be building an artificial neural network, which is an intelligent system to understand the results, or to understand the problem of COVID-19, and like making rational decisions. Okay, rational decisions concerning COVID-19 disease. Okay, now here the deep neural networks which we are using, it will be having actually it has an extraordinary ability to perform variety of functions on variety of data types. Okay, so what is a deep neural network? It is nothing but it's a function which imitates the working of a human brain in processing data and creating patterns. So it is otherwise called as DNL, deep neural learning, or deep neural network. So it uses both structured as well as unstructured data for training. So there are voluminous studies nowadays, like on COVID-19. Okay, the deep learning algorithms, many algorithms are available. Okay, so for that is for all types of tests and all types of test data, it is actually there are many algorithms, and results are available, and the papers are available. Okay, so we have actually different types of architecture which is actually used, and this is actually the model CNN model, how it is actually used and reviewed on various studies. Okay, this actually it represents a family of same architectures that is deep neural networks. Okay, now here very important thing is actually CNN is actually widely used, and other things are ResNet, VGG, DenseNet, Inception, GoogleNet, MobileNet, Exception, and other learning techniques are also used. So it is always welcome to have newer algorithms to just go for a better understanding of the problem, to better understanding and analysis of the particular problem. So the study suggests that we have different deep learning algorithms adopted for detection, diagnosis, classification, prediction, and prognosis of COVID-19. Okay, so we have public data sets as well as domestic data sets. Okay, which are used for training as well as testing. Okay, so the output metrics, or we can say that which decides that is this particular algorithm is best and not so, that is nothing but the metric. So the measurement of efficiency of the methods for a particular community is declared with the support of the parameters, namely sensitivity, specificity, and accuracy. Accuracy, you all may be knowing, I assume. That is, sensitivity is nothing but the true positive cases. That is how an individual or a person is infected or not. So specificity is nothing but true negative. So also in many other studies, area under curve, AUC, that is also, that parameter also is used for to determine the efficiency of the method. Okay, and mainly here we focus on that is deep transfer learning techniques, which will get higher efficacy, because why we are going for learning instead of just when we have seen as of now deep learning models, deep transfer learning models, we are just going to see what is meant by transfer learning. Transfer learning is a technique that focuses on storing knowledge gained while solving one problem and applying it to a different problem of the same type. Okay, so it is nothing but it is a technique which focuses on storing knowledge gained in solving one particular problem, and we apply the knowledge to a problem of the related problem or of the same type. So this is called as a pre-trained model. So for example, we are just learning, and we are just gaining knowledge in recognizing cars. Okay, the same knowledge can be applied to recognize trucks, because that will also be having 4 wheels. Okay, the knowledge which we get from recognizing cars will be always supportive for recognizing trucks also. Okay, so this is actually the transfer learning model. This knowledge, task 1 learning model knowledge is actually applied to recognizing task 2 or solving task 2. And the frameworks which are used for deep learning algorithms are like some of the things I have just explored here. NVIDIA, CUDN, and TensorFlow. TensorFlow is commonly used. It is actually an open source computational library. It was built by Google's brain team, and it was actually designed to work faster with the Python API using C or C++ processor. Theano, Keras is also publicly used and it is widely used. Caffe, Deep Learning 4J, Torch, PyTorch, Cognitive Network Toolkit, MXNet, Digits, these are commonly used. NVIDIA has developed Digits, and it is actually a web-based platform. NVIDIA, like it is also because we can go with the GPU process. So we can just, because CT images, definitely it will be just occupying large space. When you just go with a voluminous collection of images, it will be occupying lot of space. So in that case, training and testing will be a very big task. So for that, actually, the traditional deep learning models or deep learning algorithms, or whatever we are just whether CNN or any other algorithm, definitely it will be helpful. But to reduce the time, or I want the result in no time, or I want the result in less time. In that case, we can just go with the parallelized model. So parallelized model, either that is embedding parallelized model in C or C++, it will be nowadays very simple. Okay, only thing we need, because why I am telling here parallel processing means, like, it is nothing but we have earlier days we had actually single processor. Okay, so that single processor, it was helpful, okay, in solving a particular problem. Okay, now I say that I have a for loop which will be just doing 100 iterations. Okay, so that is, it will be just sequentially, it will be doing 100 iteration. When I is equal to 0 to 99, it will be doing 1 by 1 for every iteration. Okay, it will be taking, suppose take an example of 100 units of time. So I apply the same for now, because present day we have multi-core process. Okay, we have multi-core process. That is actually, I have in my laptop itself, I have quad-core processor or core-to-dual processor. That is dual core means I'll be having 2 processors. Quad core means I'll be having 4 processors. I have 4 processors, but I'm only effectively using one processor at a time. I think I'm just going in a correct way. Okay, so that one processor, it is actually, now suppose take an example, for loop, I'm just telling 100 iterations are sequentially executed in using only one processor. If I apply the same to 4 processors in parallel, it will be doing those operations and it will be producing the result in less time. Definitely, it is not that of with a single processor. So with this conclusion, we can just conclude that parallel processing models can be adopted so that the results will be produced in less time or no time. Okay, so now pre-trained models I was discussing. Okay, pre-trained models for because CT scanned images we are just thinking. So CT scan images, like it will be, that is how the pre-trained model it is actually working. The models available used for image segmentation are MASK, RCNN, YOLO, MobileNet, DeepLab V3+, UNet. Okay, so this MASK RCNN is it's a flexible framework developed for the purpose of object instance segmentation. This pre-trained model, it is actually implementation of actually the same CNN technique on Python and Keras. So it will be just creating actually the segmentation of the particular area. It will be creating a bounding box of the image, that is which will be identifying the infected portion. Okay, now in this mask RCNN, that is accuracy obtained is 96.98. The positive cases were 534 and 134 negative cases. So, and this COVID-X9 net, it's actually commonly used, which is actually 25 COVID-19 positive cases were reported, and accuracy obtained is 90%. Now it is getting improved. This COVID-X9 net is actually getting improved. And Vgg model, it is actually, the obtained accuracy in that model was 93.48, and 53 positive cases and 5526 negative cases were reported. Okay. So very important things only I'm just discussing, or commonly used things I'm just discussing. YOLO, it is nothing but you only look once. It's a state-of-art real-time object detection system. So which will be adopting deep learning models. Okay. So this particular repository, it has actually implementations of YOLO v2 in Keros. So the developers have tested this framework on different object categories of images, like face mask detection. That is when a particular person is entering into a hall, whether face mask is actually using it or not. Red blood cell detection. So it is actually these types of pre-trained models are used. And Raccoon detection is nothing but Raccoon detection. It's actually eye problem. So black eyes, that means that is a black ring will be formed as so that is Raccoon detection. So when we combine YOLO with the other transfer learning techniques, so it is actually easy for us to detect the infected areas of chest CT. Okay. And this is actually mobile net. This mobile net, it is used, it was designed by Google, and it's for mobile users, mobile devices. Actually, the pre-trained weights were obtained from a popular ImageNet database. So here, where actually there are millions of images which is actually available, and we have 20,000 classifications of images. That is very important. And this mobile net, it uses the training accuracy obtained is 98.03%, and validation accuracy is 96.88. Vgg 16, 85 and 82 subsequently, respectively, and DenseNet, it is 98 and 97 respectively. ResNet 50, that is another model, actually training accuracy is 82 and validation accuracy is 88.54%. Okay. Now semantic image segmentation using DeepLab v3+. Okay. So now here this segmentation works in such a way that labeling is assigning a semantic label to every pixel in the image. Okay. So this semantic pixel will be helpful, that is whether infected or not. Okay. So as actually these are all working in various other applications. Okay, so we can adopt always the transfer learning models so that it will be employed for that is COVID-19 also. Okay, the exception 65 model, that is of DeepLab v3 model, has accuracy of 96 and precision it is of 91 and specificity 97. MobileNet, it has actually MobileNet v2 and ResNet 101 or the other models. Okay. So, and robot surgery segmentation, this is actually a unit model, which actually attempts to address the problem of segmentation for surgical instrument. So wherever actually robot assisted surgery is adopted, so in that case actually this particular model is helpful. So it actually the problem is here it is divided into two parts. One is binary segmentation. Binary segmentation means that labeling is every pixel in the image is labeled in such a way that is the instrument or background. So if there is actually instrument, it will be marked a specific one or like that. It will be that true be marked. It will be, and my segmentation, different instruments or different parts of instruments distinguish the backgrounds, because here in the earlier case, two different categories. One is actually it is considered to be either instrument, even some paper is actually included, or physician is coming in between, so that will be considered as instrument. And the second category is background. Okay, so the multi-class segmentation is better. That is, it distinguishes various classes. And only thing is classes should be defined earlier. Okay, so that is a unit model, like a unit based, that is the convolution neural network. It is actually considered to be fast, and it has actually precise segmentation of images. So the sensitivity actually in the 3D model, it is actually 0.58 and specificity 0.99. Okay. So, and a pre-trained model for, that is image segmentation, we have seen. Pre-trained model for image segmentation we have seen. Now this is for image classification. Okay, these are the various periods in which actually the image classification, AlexNet, Net, ResNext, Net, ResNet, ShuffleNet, MobileNet. These are versions 2. Okay, so these are that is globally adopted for image classification. And one important thing, I'm not exclusively telling this for CT images. It can be used for CT images. Okay, so this is actually used for other types of image classification. So AlexNet, it is widely used and it is popular variant of CNN for that is used for deep learning model. Okay, and it has 8 layers. The first 5 layers are convolution layers, and which will be having max pooling, which will be considered as max pooling layers, and the rest three are connected layers or fully connected layers. Okay, now here ReLU, that is actually the commonly used, the activation function is used for improving the training performance. So sigmoid, I'll just give an example. Okay, so it can be concluded that Alex model has a very good performance when it is actually used. Learning model means, again, it is nothing but will be used. Now I just want to exclusively tell this one. This AlexNet, it is used in other learning models. Okay, suppose take an example. I'm just telling that is other image classification models. It is widely used. Now we can use the same thing. That is, we can use AlexNet model for CT image classification. So because it is actually considered to be a now a transfer, because same learning knowledge, same knowledge can be gathered here, or we can use it here to detect or to classify the things, whatever to our expectation we can do. Okay, so and Vgg model, this is actually again one more convolution neural network with the specific architecture it has. Actually, it is used for large scale image recognition. So this was introduced by a group of researchers, visual geometry group from University of Oxford. So they have just presented their model, Vgg model, in a workshop or in a yeah, they have just did it, and they did actually 1,000 classifications. The 1,200 classes of images were just isolated, that is defined, and with that actually they have just classified 100 classifications they made. And VGG 16, it uses 16 layers, and 19, it uses 19 layers. Okay, now here also the convolution neural network model, that is a deep convolution neural network model, it used a transfer learning framework, and uses the weights of pre-trained image net, which was held. Okay, so the VGG 16 model, which to be a convolution neural network, which trained 1 million images to classify different categories here. And Google Net is again, it has okay, this transfer is used the approach, the image, which and actually to be the most common staple architecture, and it uses the machine learning libraries such as TensorFlow, Keras, and PyTorch. And this is one of the best model, that is a CNN model for learning as well as training. Okay. Now ResNext is actually is a model on transfer learning. It is actually deals with the problem. It collects the information, the knowledge from the ImageNet database, and it is transferred to the task of human motion recognition in multi-radar. So it will be just it aggregates a set of transformation with the same topology. So there is one more dimension adopted here, cardinality. Apart from depth and width, it uses another dimension called as cardinality. Okay, SqueezeNet, it is actually another CNN architecture which has 50 times less parameters than that of AlexNet, but it is equivalently better because it is actually the accuracy will be, we can expect the same level of accuracy as that of AlexNet, and it is used actually in this model can be used for FPGAs, which has actually limited chip memory. Okay. ResNet, which was proposed in 2015 by Microsoft Research, and this is otherwise called as residual network, where actually we have that is an input to one layer is passed directly or to some other layer. Now you just this input, this is actually input X is nothing but input to this layer, and this is actually again applied to another layer. So here we get ReLU is a function which is actually giving some function f of x, and when you just give this one, it is producing another result f of x plus s. Okay, so this is actually the residual block or the residual model. DenseNet, it's another architecture, another convolution neural network model. So it connects each layer to every other layer in a feed forward fashion. But as of now, this is actually the first one which uses feed forward model. Okay, the traditional models like we have L layers and we'll be having L connection. That is one connection between the layers. Subsequent layers like we have direct connections of L into L plus 1 divided by 2 direct connections we will be having here. Because one more thing is this actually produced an accuracy of approximately 98%. Okay. ShuffleNet, it introduces 3 variants of shuffle unit. Okay, so that is each group will be taking one input. 3 input channels. So and because of that, actually we'll be having varying level of convolutions. That means each group will be taking a portion of the input channel. That is, we have 3 variants and 3 groups will be formed, and 3 will be taking 3 different input channels. Okay. Now, the taxonomy of machine learning and deep learning algorithms, which are adopted for detecting COVID-19 patients. So one is actually we can classify into 2 categories. One is diagnosis, the other one is treatment. One is diagnosis and the other one is treatment. So in the case of diagnosis, we have we use medical images for diagnosis, and the non-invasive measurements and sound analysis. Where sound analysis are used, that means we can just go, like whenever we have the online diagnosis and all, like online, we are just going checking for a we are going for a practice or a medical assisted system, virtual assisted systems we are using. In that case, cough and breathe will be just considered. And medical images, CT scans, X-rays, COVID-19 severity cases, like other forms of images will be considered. Okay, so and treatment, drug development and vaccine development. So these are the various levels in which actually we can say that we go with the that is deep learning models. So the applications where we can just deep learning algorithms or deep learning models will be used in COVID-19 disease management. Okay, so this particular deep learning model in AI, it is actually successfully used in the identification of disease clusters. Clusters are very important here. Disease cluster, that means group of people who are infected, monitoring of the cases, prediction of future outbreaks and mortality risk, and diagnosis of COVID-19, and disease management by resource allocation, facilitating and training, and record maintenance, pattern recognition for studying the disease trend. So these are various levels with which actually we can work, and several applications that are garnering a lot of interest, or you can say that the challenges or future scope we have in this particular disease detection, or deep learning in prediction and tracking, deep learning in contact tracing, deep learning in monitoring of COVID-19 cases. One by one we'll see. Deep learning in reducing the burden from medical practitioners and healthcare staff, deep learning in protein structure prediction, deep learning in development of therapeutics and vaccines, deep learning in curbing spread of misinformation, deep learning in genomics, deep learning in early diagnosis. So early diagnosis are just, we have, one of my scholar is working on this one, early diagnosis. So these are the various ways with which actually the applications can be developed. That is for deep learning applications can be developed. That is with respect to medical imaging, diseases tracking, protein structure prediction, drugs discovery, and virus severity and infectivity. So first one is deep learning in prediction and tracking. So we can just forecast the spread of the virus, and we can just put an early warning system. That is the ROK Sedu. It is actually, we can say that it's like it's working for tracking only. Okay, and extracting information from social media platforms, calls, and news sites. So with that, actually, we can just go with the new model. So it provides useful information about the vulnerable regions and for prediction of morbidity and mortality. So the death, what are the severe cases and the death possibilities, death cases which are possible. And blue dot, it is actually which is identified as a cluster of pneumonia cases predicted. So this particular tool, it predicted the outbreak and geographical location of the COVID-19 outbreak based on available data using machine learning model. Health map is another tool which actually collects the publicly available data on COVID-19 and makes it readily available to facilitate the effective tracking of its spread. And we have other also like other models, like many algorithms and many models, many apps or mobile apps are available now for tracking and prediction. Okay. Now, how this particular model is working, like we have the common model works, like we have the data set and the data pre-processing is made, and clinical data, textual data, and genomic data categorized, and we deep learning, it is category and machine learning, which is part of automation. Just go with the detection, prediction, diagnosis of the disease, based on the final result concluded. Okay. More deep in content. So augment a mobile health application. Okay, where devices like watches, mobile cameras, and we can have a wearable can be diagnosis and contact and efficient monitoring of COVID-19 cases. Okay. So applications like AI for COVID-19, which will be just uses this what I wanted to tell, audio recording. So which uses samples of cough, which can be used supported for telemedicine, so that we can easily just detect whether it is actually a normal one or that is based on the symptoms that the person who is actually telemedicine care can easily detect. So this is actually the sample model of contact tracing. Now here, what first quarantine upon first symptom, test widely and isolate quickly, and identify the contacts who are actually nearby and quarantine the contacts. So this is actually, we can say that, put the box in the virus. So deep learning in monitoring of COVID-19 cases. This is actually monitoring. Now we have seen, you can ask me tracking, tracing, what is the difference? Each one will be having its own differentiation. Now here, based on the clinical settings and we can monitor based on the data derived from vital statistics and clinical, deep learning may information for resource allocation, decision by prioritizing the need for ventilators. This is actually a very critical component, because a few months before we had a scenario like people who are in need of ventilators were not given or assigned ventilators. So priority, based on the priority, we can just provide the ventilator or oxygen support. So the respiratory support systems can be adopted. So that is actually, that comes under monitoring. Okay. So we can just go with the predicting the chances of recovery or mortality COVID-19. Okay. And to provide daily updates, storage, and trend analysis, and charting the course of treatment. Okay. So this is actually the severity prediction model. Okay. Now here the efficient net is the model used. So here the CT images are just captured and a proper network CNN is adopted and the clinical features are adopted. Now, very important thing I would like to just tell here is a combined severity prediction. So based on the image as well as clinical data, a combined severity prediction model is adopted, and also a survival forest, that is actually the person who is actually present in one location will be for that person, that is what are the different chances, like whether actually the person is actually he is in need of particular treatment, or he can just go with another treatment, or he's actually asymptomatic. So the tree structure will be, a forest will be framed. So based on that, that is again a prediction is made, that is a clinical database prediction is made. So similarly for the chest X-ray, again that is a survival forest will be that all this conclusion will be combined together to form a comprehensive or combined progression prediction model will be considered for severity prediction. So this is actually, for this case, it is exclusively, we need to just only think about deep learning models. Okay, so deep learning models actually, which can just, so if we can make the medical practitioners and healthcare staff the burden can be reduced for them. So we can just go for a triage system. This triage system will help them and will just make them to reduce their work burden, because these times they were suffering a lot, because when we just go with an automated processes, like it will definitely it will reduce their burden. Okay. So the training to practitioners and determination of mode of treatment and care by analyzing clinical data using some pattern recognition approaches. So we know very well that is only after this test, this has to happen, and this has to happen. This patient has to go to this stage. So this particular step-by-step process is known. So where actually definitely a medical practitioner or a healthcare worker, it is, if you feel that it is not required, we can automate that process. And digitization of patient reports, and also by offering solutions which will minimize their contact with the patient. Okay, so we can just digitize the patient report, and telemedicine is also one other suggestion. If a person is not, is actually COVID negative by nature, so he need not come and attend the hospital scenario. So he can just very well just face the telemedicine, and he can just go with the preliminary solutions he can face, and he can just come out of the problem. Okay, so this DL model can be used for classification of patients based on the severity of symptoms and genetic disposition and clinical reports in different categories. Like we can just categorize that as mild, moderate, and severe. So that different approaches for every case, for mild case or for moderate case, for severe case, we can just use different approaches and we can just handle these patients in more effective way. Okay, so and telemedicine, it is actually one of the that is one method which is used to eliminate the need for frequent and unnecessary hospital visits. Need for frequent and unnecessary hospital visits by distant monitoring of cases and recording of patients' data in asymptomatic cases or patients with the mild symptoms. They can sit at home and they can just do a telemedicine. So now we can just go with the medical chatbots. So this is actually one other model where actually we can just the practitioners give consultations, thereby reducing the physical crowding of hospitals as well as spread of infection, and thus prevent weighing down of efficient operation of critical care services. The chatbots, like we have we have a Clara. It's actually a chatbot which is actually used disease control. Okay, and this prediction for them, which was actually reducing the mortality risk of patients, can be used for can be the like machine learning algorithms or DLL, that is deep learning algorithms, will be used. So which were used for that is extracting the features from the training data set. Okay, so So acute respiratory distress syndrome, it's actually, this particular SARS virus. It has actually, as of now, we have concluded with only 5 tests, 5 test models, and also the severity is also like 3 or 4 categories. As of now, it is actually classified, the severity model. Okay, so there is always a possibility that this particular classification, it will be varying. Okay, so first 5 days, one treatment, that is if asymptomatic, one treatment, and if symptomatic and it is also not actually risky, that is separate treatment. And if it is actually riskful, then it is another treatment. If it is actually oxygen support, then it's another treatment. And if it is actually ICU care, so then it is another treatment, that is ventilation. That's a separate treatment. So we can just go with the actually different models. So service robots can be used, which is actually AI embedded. Okay, which will be just used for cleaning the hospital or cleaning the buildings, disinfecting and monitoring the hospital setups or any other building, because everywhere it is mandatory now to clean and disinfect the place. Okay, so where actually we can use, and this is actually how the diagnosis can be, hospital setup diagnosis can be just increased medical care. What it is actually, it is called as diagnosis. And care when it is actually a chronic disease, like it can be now here it is not only COVID-19, it can be anything. Okay, so we need care means here we need actually contactless care, medical care is required. Whenever actually it is contactless medical care, what is actually the what models we can, what are the automated models, what are the AI solutions we can just give. Pathways modeling, automated simulation, prognosis, and robots we can use. Okay, and similarly for logistics. Okay, in the shortage of, let us take an example of shortage of skilled medical staff, shortage of skilled. So we need actually a networking, or you can say that we want an automated planning of resources. Okay, suppose take an example in that is COVID block, usually like where 10 staff nurses will be there. In that place, only one person will be there. So in that case, how the automated planning will help? That is, we can just even if we give a planner for them, that will be helpful. That is, if a person who is actually working for 2 to 9 shift, 2 o'clock to 9 p.m. What is actually the schedule? What is the schedule or the plan they need to follow? So if that support we can give, if there are 50 patients or 25 patients, if that for them, how care they can give, when actually they should give medicine, when they can give injection, when they can give food, and when they can give water. So these are all nothing but schedule. This will be scheduled appropriately. And if we give even that particular tool for scheduling tool, that is actually that will be helpful for the health workers. Okay, and deep learning in predicting the prediction cases. Okay, so it is actually the protein predictions. It's very important because whenever actually the protein is a very important component in this COVID-19 scenario, we need to take a lot of protein rich food. This has actually a high impact on the entry of the virus to our body. So and also its replication, and provide useful insight that can pave a way for drug development in a short time. Okay, so AlphaFold algorithm of that is Google DeepMind employed deep residual networks called ResNets for predicting protein structures of membrane protein and protein 3A, NSP2, NSP4, NSP6, and papain-like C-terminal domain of SARS-CoV version 2, which will give huge impetus to drug discovery programs. Deep Tracer, it is again a program based on customized deep convolution neural network, so which will be deriving the protein complex structure of SARS virus from that is SARS virus. It will be just the amino acid sequence also it was actually given. Okay, this is not required anyhow. This is a sample how actually it is actually the protein structure is evolved. Deep learning in development of therapeutics. So deep learning techniques can boost and complement traditional technologies by reducing time required in bringing a drug from bench to bed. So by speeding up lead discovery, so virtual screening and validation processes, we can just definitely go with a better system. So it can accelerate the pace by deriving useful data for drug repurposing or drug repositioning by screening properties of already approved and validated drugs based on molecular descriptors and properties which may not be possible for a human expert. Let me give one example. So now you might have all heard that is what is the need of remdesivir. Remdesivir injection, that is 6 vial. Okay, 6 vial we need to give it to a COVID that is who are pneumonia virus infected person. Okay. So COVID-19 infected person. So for them actually this injection remdesivir, it was actually that was the remedy in the earlier stages. Okay, even now it is actually used. Remdesivir it is used, but what is happening? So there is actually a lot of demand for this particular injection. So what is happening? We can just provide a supporting system which will have nowadays. Actually, it is there are so many tools available, or many there are many online web portals and mobile apps were developed for just bringing the injection, or that is a useful tools like that is cylinders, oxygen cylinders to a doorstep. We can just get everything within less time, and we cannot say within no time, within less time we can. So we have supporting models like that. Many of our that is seniors also have just developed models for that. They have developed web tools for just that is a resource allocation. This is actually a resource allocation. Here, human expert will not be helpful. That is because, suppose take an example, I need a remdesivir which is actually available in Chennai or Coimbatore. I need it in that is in my place. So I can just go with the that is so if I need to first of all check where it is available. So resource availability, that I need to check. So for that actually, so first of all, the person who are the pharmacy person who is having the medicine, they should have actually, they should give the support, so that they should tell that first it is actually available in Coimbatore or Chennai. Then only we can just retrieve the result. So again, this tracking of medicine, where it is reached, or whether like how we are logistic positioning, how it is that is location mapping systems are working. So the same way it will be tracked. So this is actually like how the medicine or drugs, exclusively drugs, how it is reaching the end user. And benevolent AI, it's actually a deep learning model which will be used to accelerate the drug discovery program. So discovery program itself, that's the biggest task. And so discovery, and it's also that is to just or to surrender, or can say that to give appropriate medicine to an appropriate person, and in time, that's a very important thing. Okay. And another study, like which is combined with virtual screening and supervised learning to identify potential drugs against COVID-19, that is also talk of the town now. So we can just go with the that is network-based system of pharmacological methodology for finding potential drugs for SARS-CoV virus 2 from the already existing drug molecules. Like that's what I'm telling now. Here, remdesivir is like that only. It is not actually. It is for viral infection. This medicine, it was actually earlier it was used for viral infection. Now only, that is when this in late 2019 and 2020 only, they concluded that taken this medicine, and they have identified that this is actually useful. This is actually, they get remdesivir is actually helpful for just COVID infected patients. So this is nothing but existing drug molecules. They can just go for a new combination. So and the other models, many other machine learning models and deep learning models are also helpful. Now, there are also few projects, that is Polyform DB, which is actually successful in identifying candidates against COVID-19. Okay, so this is the one. Actually, here the data is collected, COVID-19 data, it is collected, or a collection of data is collected, and epidemiological data and clinical data, genetic data, all are just categorized. And here, that is, we go for a database management and processing, where actually deep learning algorithm is adopted, and the preventive cares and therapeutics where it is required, diagnosis, hospital operation, everything is classified. Okay. So deep learning in development of vaccines. Okay. So now also like softwares, as well as there are many softwares which are actually helpful for that is vaccination. So Vaccgen reverse vaccinology, it's actually a machine learning platform which is actually a supervised classification model which actually predicts the possible vaccine candidates for COVID-19. Okay. So in curbing spread of misinformation, so that definitely this is actually a need of the hour in this pandemic scenario. There we had actually a lot of misinformation and calculation based on that, so that we had a lot of problems understanding the knowledge, awareness, and practices toward COVID-19. So by the tapping information from social media platforms like Twitter, Facebook, or any other social media, which can help in devising the strategy to assemble and disseminate timely and correct information for mitigating the impact of COVID-19. So now here we can just identify the trends and sentiment analysis and provide information regarding the origin of the false information and help in curtailing the rumors and misinformation. Okay, so it will be just presenting a clear picture of the recovery rates, accessibility, and availability to healthcare, and identification of the gaps which is associated with that. Okay, now here we can just the evidences which is related to the latest updates on the evidences of diagnosis, treatment, spectrum of symptoms, and therapeutic outcomes, or which is also required in this scenario, in this situation. Okay, so this particular system, if we are, that is, whenever we just go with a newer models like this, that is deep learning based this a tool of this, which is actually helpful for this particular problem. So definitely it will be helping the public in overcoming the fear and panic situation. Okay, so the misinformation, it can be a false information, it can be a rumor, it can be a spam or fake news or disinformation. Disinformation itself, it means something that sometimes a hospital itself will be giving some information which is actually false in nature, or from the hospital some news will be coming that is actually false in nature. Some people, for some VIPs, will be getting an information that is sometimes suddenly they have about their demise, but actually it might not have happened. So this is actually the disinformation. Okay, deep learning in genomics. So there is an author that is Randava, he has devised a method for fast and accurate classification of available SARS genomes by applying machine learning on that is a genomic signatures. Okay, so there is another author, Wang. He has actually developed an ontology-based model prediction framework, and that is ANN model, to evaluate the side effects of traditional Chinese medicines for treatment of SARS-CoV-2. Okay. So in genomics, what are the opportunities? Okay, so the acceleration of drug discovery. So that means we can just think about any other that is genomics, which will be helpful for which can just give new drugs. So which can get actually from the existing models, which can create a new model, and we can create new drug discovery. So without affecting the human body, like how we can just develop. Then disease diagnosis. So prediction of the disease associated mutations. And the next one is, now here actually this picture I just got for cancer detection, but again it's actually a transfer learning model, so we can adopt it for this one, COVID-19. Okay, so this is actually the opportunities which are existing for deep learning that is related to genomics. The same thing we can use for COVID-19. Okay, and then the next one is early diagnosis. Deep learning in early diagnosis, which is actually need of the hour. So AI was actually used as used for detection and quantification of COVID-19 cases from chest X-ray and CT scan images. So earlier 3 models, antigen test and Rt Pcr, like everything I just told. Now I am just for image-based classification diagnosis only. I'm just talking. So this is actually chest X-ray and chest CT scan images. So the researchers have developed a deep learning model for COVID-19 detection. So that is actually called as CoVNet for differentiating COVID-19 and community-acquired pneumonia based on visual 3D and 2D and 3D features extracted from the volumetric chest CT scan. Okay. Yeah. Okay. So, so next one is there are deep learning algorithms, which is actually multi-objective models, and we have CNN models, which is actually exclusive for COVID-19 diagnosis. That too for chest CT. And chest CT, I have just given some 5 models where it is actually 5 different cases. And what are the opportunities in that one? That means what are the drawbacks in that one I have identified. And so COVID ResNet, it's actually another tool, which is actually automatic and descriptive, discriminative learning rate. And it is actually having a comparatively better than COVIDNet. It was concluded as it is better. Okay, but not for all types of data sets. We need to check that one. And COVID MTNet, like it is actually, it's another model, neural network model, that is RNN model for detection and localization of regions of interest from both X-ray images and chest CT. X-ray images are 2D and chest CT actually scan, it is actually 3D image. So we can just detect regions of interest. So AI-based classifiers are also helpful for predicting the outcome of Rt Pcr results of COVID-19 cases. And because here 16 simple parameters were derived from complete blood profile. Okay, so this may find application in reducing the number of Rt Pcr tests in resource poor settings. That is where actually we have the sophisticated CT scanners are not available. Okay, in that case, actually we can just go with this one. So this is actually the working model, or you can say that where we have a pre-processing, feature extraction, data augmentation, segmentation and classification, and transformation function. This is actually the most important one. So now pre-processing, as you all know, like it is actually, it will be having data sets will be collected and it will be split for training and testing. And here, and then in the feature extraction, the features are extracted and it is split in the case of data augmentation. So here we'll be having a training and testing and validation of the images. Okay, so we use deep learning algorithms here, and the training generator, in this case segmentation and classification, it is combined together in the case of, because of it is combined, then only we call this one as deep learning. Otherwise we will be thinking about this one as a machine learning algorithm. Okay, with this model we have that is we get actually a new model which is actually compiled. The result which is coming out of segmentation and classification, it is applied to a transformation function. So where actually a classification is made, that is a softmax classification function is applied to detect COVID-19 cases. Okay, so these are the data sets actually. I used Kaggle data sets and GitHub data sets. Okay, just and also this is actually India COVID-19 India data set which we are working now. No, I'm not sure. Okay, so this GitHub data sets actually it is helpful for us because it for all the repository, it is actually complete. So this is a classification method for COVID-19 diagnosis. So, but here the new there is always a need for a new DL model, that is a deep learning model, which is actually better than the existing COVID-19 cases following up, and in the case of epidemic as well as pandemic scenario. And one more thing is like we need to develop models which will work for heterogeneous data sets. To cover all the available data space, we need to have better training models also, which will just have large volume of data. So whenever we train large volume of data, then definitely testing will be easy for us. And another one is parallelized deep learning algorithms. It's very much required. Parallelized deep learning algorithms are very much required, because definitely it will improve the efficiency of the system. So whenever we just think about parallelized models, we have we can just the input model, the input algorithm, whatever we are using, or the input data set, whatever we are using, every stage, even either feature extraction or sorry, pre-processing, feature extraction, image segmentation, classification, everywhere we can apply parallelized algorithms. We can go with the parallelized algorithm, so that in less time, definitely we'll be getting the result. That is actually the beauty behind parallelized models. Okay, and these are my major references. Okay, let me just have one more thing, that is what I just extracted and got the results from GitHub. Okay. So is Word file visible?
No, ma'am. No.
Wait. Is it visible now?
Yes, ma'am. Now it is visible.
So this is actually the one which I just got it from GitHub, and also we tested it. This is actually for early detection of COVID-19, the deep learning model, CNN model, which is actually used, and this is actually the model where actually the CT images were given, and the CNN model, which will be having multiple layers of max pooling, and also that is this one, the other layers, which will be evaluating or which will be just going for multiple image segmentation and classification models. And with this, actually, we can just detect whether COVID-19 infected or not normal. Okay, so this is for chest X-ray images. Okay, so this is actually the this is predicted as COVID, and this is normal. Okay, so data which is collected, it is actually COVID-19 from GitHub. It is collected. So this was the study. Actually, it was limited to 130 patients, and for training this particular model, it was the multiple layers were adopted for that is using CNN, and that infected patients with pneumonia may present on chest X-ray, or sometimes like it is actually CT images. With this pattern only, that is we can conclude whether actually it is positive or not. Okay, this is chest X-ray positive case. Okay, and here the two classifiers, ReLU and sigmoid classifiers, are here used. Okay. The framework uses TensorFlow, and that is the two classifiers are used, which is nothing but ReLU and sigmoid. Okay. For that 136 images, actually, it is the whether it is actually positive or negative, it was concluded. Okay, and this particular model actually accuracy obtained is 98 and loss it is actually 0.04. And the deep learning models, it will be just this actually works for only chest X-ray, Okay,